Hi, my dear friends. Today we will discuss about memory interfacing. Right? In the last class, we discussed about what we discussed, that is minimum mode, maximum mode, and we discussed the minimum mode organization, that is configuration, and then we discussed the timing diagrams for the read operation and write operation. Now we will go for the last topic in this unit, that is memory interfacing. Right? So, many students, please pay attention. This is very important topic. Right? We are having the processor. Now we are suppose I want to interface some memory. I want to interface some memory. Then see, basically first we will go for in 8086 memory means what is the use of main memory? Memory is used to store the programs and data. This will be classified into processor memory or primary or secondary main memory and secondary memory. We can call primary memory or main memory. Now coming to the processor memory registers inside a microcomputer, right? So suppose general purpose register AX, BX, CX, DX. What is the use of these registers? You can store the data temporarily. Store the data as temporarily, right? So there is no speed disparity and cost is high. Now coming to the primary memory, storage area which can be directly accessed by microprocessor and store programs and data prior to execution, and should not have speed disparity with the processor, right? So what are the examples for ROM? The ROM examples are ROM, EPROM, static RAM, and dynamic RAM. Secondary memory means storage media comprising of slow devices such as magnetic tapes, disks. All these are comes under a secondary memory, right? So before going to discuss about interfacing of memory, first we should know all these things, right? Now coming to the already we told there is an even bank and odd bank. So odd bank means when a0 is equal to 0, then even address memory bank. When a0 BHC bus high enable is equal to 0, then we go for odd address memory bank. So we know that 8086 microprocessor is having total 1 MB of memory. In this 1 MB of memory, we are having address lines from A0 to A19 and data lines from D0 to D15, right? So in this we are giving address bus A0 to A19. This is for lower data D0 to D7. Higher data is D8 to D15, right? So address bus, and this is called data bus. Address bus means A0 to A19. Data bus is lower order data, higher order data. D0 to D7 is lower order data. D8 to D15 is higher order data, right? See, coming to the memory organization in 8086, based upon the two signals, remember BHE bar and A0. BHE bus I enable and A0, we can call read, write, byte, and even address. Even address means D0 to D7. So when it is 0 and 1, that is D8 to D15, we can access. BHC 0 means we can access D8 to D15. Next, read write word at an even address, right? Even address again 0 0 means D0 to D15. Both are 0, we can access both D0 to D15. Now coming to the raw word. Remember this is word and this is we are calling about byte, right? So my dear students, please pay attention. When it is 0 1, then see D0 to D15 first operation byte from odd bank is transferred. Odd bank. So here we are calling it is odd bank, and here we are calling is it a even bank. So for odd bank we are giving a bus high enable, and here we are giving A0. Just now I told, right? See A0 for even semester, BHE for odd bank, right? So in this way. Now go for the memory organization. See, actually available memory space is totally EPROM plus RAM, right? So this allows equal address space in odd and even bank for both EPROM and RAM. It can be implemented in two ICs, one for even and one for other odd IC, one for odd ICs, right? Now coming to the interfacing of SRAM and EPROM. So memory interface, it read from and write into a set of semiconductor memory IC chips. And EPROM is for only for read operations. RAM is both read and write. Remember, both read and write. In order to perform read write operation, we have to memory access time should be less than read write time of the processor, and chip select signal has to be generated. CS, chip select. See, so we are using different here. Chip select is CS, chip selection. So chip selection lines we have to select and control the signals for read write operations and allow the address for each memory location. Right, now coming to the interfacing of SRAM and EPROM. So suppose consider this is SRAM and this is EPROM. SRAM and EPROM, right? So The number of address lines are how many? 20, right? When 2 power 20 means how much? 10 power 10,048 10,48,576. In kilo we can write 10,024 into k, right? That is 1,000. That is 1,000,000, right? This 1024 can be divided into 512 kb into 512 kb, right? This can be divided into 512 kb into 512 kb. 512 kb for even bank, 512 kb for odd bank, right? So the what is the range from 000000 to double F triple F, 000000 to double F triple F, right? So in the EPROM chip selection, we are having VCC ground. This is the address bus and data bus. Same address bus and data bus. Same. Now coming to the interfacing. See, total we are having how many? 0000 to 000000 to double F triple F, right? This can be divided into even bank and odd bank. 512 kb for even bank, 512 kb for odd bank. Suppose this is best example is if you open the textbook. When you open the textbook, if you see the left side consists of all odd numbers. That means 1, 3, 5, 7, 1, 3, 5, 7, 9, 11, 13, like this. If you see the right side, all are 2, 4, 6, 8, 10, 12, 14, 16, 18, like this. So in order to find easily to the data, that's why we are using this even bank and odd bank. So this is about interfacing of memory interfacing in 8086 microprocessor. Remainder students, thank you.